In this video we're going to start talking about the concept of an antiderivative. And you'll see here that I gave you the derivative and I'm asking you to find the function. Well, when we do a derivative we always would bring the power out front and then decrease the power by 1. Well, working backwards, I hope it's logical that we would just do the opposite. We're going to raise the power, and then we're going to, instead of multiplying, we're going to divide by the power. So I'm going to write a 1/3 out front, but you could just divide by 3. Now check that. If you were going to find the derivative, 1/3 multiplied by 3 is 1. We drop the power, certainly is x squared. Next, the e to the x is its own derivative, so I hope it makes sense that we're going to need an e to the 2x. Okay. But the derivative, if you kind of check this, the derivative of e to the 2x is e to the 2x multiplied by 2. Well, in the derivative here we don't have a 2, so there must have been a way to cancel that, so we must have had a 1/2 out front. Now check it. The derivative of e to the 2x is e to the 2x multiplied by 2. 1/2 multiplied by 2 is 1. And it gets us to this. Next, again we're going to raise the power and divide. Derivative of e, or antiderivative of e to the x is e to the x. Okay, let's kind of work our way back up now. Here, we have 2x, and the antiderivative of cosine is sine, because of course the derivative of sine is cosine. So we kind of just use what we know about our derivatives. Okay. Next, the antiderivative of secant squared is just tangent, because of course the derivative of tangent is secant squared. Last one. Well, let me start with the easy part. We're going to have a 4x here at the end. This part always gives people a little bit of trouble because they look at it and they think, well, I could write this as x to the negative first, and then just kind of using the same logic I used over here, I could raise the power, but that's x to the 0. And then I divide by 0. Well, that doesn't make any sense. You can't have x to the 0 divided by 0. So this concept right here is not going to work. So what we need to do instead is think about the functions we know and see if there's one that has a derivative of 1 over x. In fact, there is. The natural log of x has a derivative of 1 over x. Okay. Now, unfortunately, at this point, every one of these is wrong. Okay, we're missing one thing, and that one thing has to do with the fact that if I had a, let's say, a plus 3 here, when I found the derivative, it would have been gone. If I had a plus 7 here, or minus 10, any constant when you find the derivative is gone. So I'm not assured that those are actually the derivative, or the functions that have that derivative, unless I make some notation of that. So every one of these, I need to write a plus c. And that c stands for constant, and it's just notation saying there could have been a constant that when I found the derivative would have been gone. Well, so let's go to a situation where we maybe could find the constant. Okay, let's think about this. So we know from the previous slide that f of x is 1/3 x cubed plus a constant. Well, now I'm telling you that the original function passes through the point 3,9. So that means if I plug 3 into the function, I should get an answer of 9. Well, of course, 1/3 multiplied by 3 cubed is 9. So the constant must be 0. So now I can be assured that f of x is 1/3 x cubed. Okay. Now, of course, the constant might not always be 0, it just was 0 in this case. But this is the way we can actually figure out what the constant is.